This meeting is being recorded.
Hello, everyone. My name is Chase, and I am joined by my team members Naga Sai and Arjun. For this presentation, we will be discussing what we have learned in the two articles, A Roadmap of Agent Research and Development, Autonomous Agents and Multi-Agent Systems, and Multi-Agent Learning for Engineers. Next slide. To begin, can you go back one slide? To begin, I'll go over a roadmap of agent research and development as it relates to autonomous agents and multi-agent systems. I will also be discussing the key concepts, terminology, and applications of agent-based computing. Next slide. Autonomous agents and multi-agent systems are a modern way of solving new and hard software application problems. The agent-based view is a powerful tool that is used to rethink and even improve how software is implemented. Agents are being broadly used for many applications. Some applications, such as personalized email filters, use agents, and at the same time, large applications, such as air traffic control systems, use agents as well. Since agents are used in so many situations with vastly different use cases, it's important to have a solid definition of what an agent is. So what is an agent? Next slide. There are three things that are important to understand when looking at what an agent is: situatedness, autonomy, and flexibility. Agents will always be found situated in some environment that they are to monitor. They do this by receiving sensory input from the environment, and then they perform an action on the environment as a response. There are many places where an agent can be situated, such as in a physical location or the internet. Agents are also capable of autonomous action, which can be used to meet some objective. This means that they should be able to act without direct intervention from people. Lastly, agents are able to meet the needs of the objective in a flexible manner as needed. Environments are constantly changing, so agents need to be responsive, to act in a timely manner, and proactive to show opportunistic and goal-directed behavior when appropriate. They should also be social in the way that they interact with either people or other agents. This is critical for problem solving and to help others with their duties. The main component of an agent-based system is that the system is conceptualized by agents. These systems are designed and implemented with the key abstraction being agents. Agent-based systems can have one or more agents. However, if they have more than one agent involved, then they would be considered a multi-agent system. Multi-agent systems, which are implemented and laid out by several cooperating agents, tend to be better for solving problems that are multifaceted. They also tend to be more complicated in structure and display complex problem solving. The interaction between multi-agent systems are primarily cooperation, coordination, and negotiation between agents to come to a solution. Multi-agent systems at their high level of interaction are what show the primary differences and advantages of agent systems from other programming paradigms. Next slide. The history of autonomy is tied to the history of autonomous agents is tied to the history of research for many different computing fields. Autonomous agents bring together knowledge and concepts from other related fields to produce a new and useful concept. The main contributors to these autonomous agent concepts are artificial intelligence, object-oriented programming, and human-computer interface design. Next slide. Artificial intelligence is by far the main contributor to the field of autonomous agents. AI is what is responsible for building the intelligence compounds of the systems, which are able to respond to the changing environments. The intelligence is what makes an agent function. Agency would seem to be the whole goal of AI, but in fact, most AI research, especially in the early days, was focused on the individual elements of AI, such as learning, problem solving, and reasoning. It is the combination of all these components that would eventually lead to the creation of agents. One very closely related field within AI is that of autonomous agents is AI planning research. AI planning research is focused on knowing what to do. Agents' jobs are to take in information and then decide what to do, so it is easy to see why these subjects are connected. AI planning has a paradigm that is most often connected to the stripes planning system. The typical stripe system has certain components. First is a model that represents the agent's environment. The second is a specification of the actions that an agent is able to perform. And the third is an algorithm used for planning that takes all the tools, input, and state to produce some kind of plan. This is a very useful and similar structure to that of autonomous agents. Next slide. Objects and object-oriented programming have very similar characteristics to that of agents. Objects are entities that capture state, perform actions, and communicate. This can make it difficult to see the differences and novelty of agents. However, there are some key differences. The first is the degree in which objects and agents have autonomy. Objects are able to show autonomy by the way they manage their state. The difference is that they're not able to control their behavior. Agents must be able to control their behavior. Common goals cannot be assumed as in the case for objects. Agents request action among each other while objects invoke methods on each other. The second difference is flexibility. Agents must show flexibility in order to have autonomy, as discussed previously. Objects do not seek to have flexibility and autonomous behavior. The third difference is that agents are considered to have a single thread of control. In object-oriented programming, it is a system that has a single thread of control. Active objects have some close similarities to this concept. However, they are not capable of flexible autonomous behavior. Next slide. The typical way we as humans interact with computers is through direct manipulation. We tell the computers to enact some function, and they do just that. This is a one-way interaction that leaves the user to do all the thinking. It'd be much better to have a system that was capable of thought, that would take initiative and cooperate with the user. This would still only be a semi-autonomous agent, though. These agents do exist and are often referred to as expert systems or digital butlers. These agents are most often being used in information management systems such as web browsers. Next slide. Agent architectures and reasoning architectures are continually progressing field of research. There is constant work to see where these architectures can fit in and improve usability in different environments. It is often hard in practice to see where this can be done and to test which architectures are most effective. As agent technology continues to progress and effort is made to get these agents out in their environments, it is clear that there is a growing need for better development environments and programming languages for these systems. Most of the implementation of agent technology has been put together in a less than desirable manner. These tools would help developers have a layer of abstraction over the agent architectures. There's an effort to make such systems. However, the technology still has a long way to go. Next slide. All right, next up is Arjun, and he'll be going over multi-agent systems.
Thanks, Chase. My name is Arjun Yadav Mattapalli. I'm a graduate student, applied computer science. Here, I'm going to discuss about the multiple multi-agent systems in artificial intelligence. The multi-agent system study is based on like the name. The name is taken as distributed artificial intelligence. It is used to address the systems which are having semi-automated systems and fully autonomous components. Traditionally, DAI is divided into two substreams. One is distributed problem solving, and the other is multi-agent system. The distributed problem solving is like it solves the problems by using a group of modules which they work together like as a team to achieve a specific goal. and they in doing so, they do share the data among themselves. That means they communicate each other to achieve a particular goal. DPS systems are like interaction tactics are considered as important elements in achieving those goals. Multi-agent systems. The other DAI system is that it is a loosely coupled network to solve the problems. It works together to solve the problems that are beyond an individual capabilities. They like as the DAI, they do share the knowledge among themselves, and the issue solver agents are self-contained and can be diverse in nature. The basic characteristics of MAS systems, multi-agent systems, are that each agent has a certain point of view. That means each has some knowledge and it do its own task. There is no system control at global level, and it is having a data which is distributed, and the computation in this system is asynchronous. The main problems in designing and implementations of this multi-agent system is that it doesn't know. We don't have the particular structure to interpret the results in different, as I said, it is having multi-agents working together. It don't have a particular system to gather and analyze all the results, and it don't have a language, a particular language or methodology to communicate with each agent, and avoiding potentially dangerous interactions. That means we have to achieve our goals by avoiding the interactions between the agents. That means the mall operations between the agents. And the other thing is to find a balance between local computation and communications. And if we don't control these, control the tasks of multi-agents, it will be hazardous to the task. The basic applications of MAS are the initial days, they are applied for air traffic control, where they the multi-agents create different plans for different flights. For example, if a plane needs to have a flight plan, it has to see the features of the timings, and it should be in coordination with the other agents which they are planning for the other flights, and the landing, the distance to travel, the safe distance to travel between any two flights. To do that, agents resolve the conflicts by choosing and resolving the agents by themselves only. That means these agents which plans the flight plan, they don't need to coordinate with the other agents and to change the plans accordingly. And the other application is distributed vehicle monitoring task. It is used for monitoring the vehicles in a particular area. Here the agents are distributed globally, where each agent has its characteristics that with the sounds of the vehicles, it detects the type of the vehicle and its motion and its exact location. In its that shares the data with the other agents to monitor the data of the vehicle which is traveling, to have a safe ride and all. And blackboards, these are like simple data structures where the agents write their data and communicate with each other by writing something onto the data structures which are already designed in the systems. Cooperative multi-agent interactions. Multi-agents are collaborated and use cooperation strategies to achieve a single goal, like a for example, a Robocop robotic and synthetic soccer. Here, multi-agents are implemented to do a task of winning a game in a cooperative manner. That means all the agents are having a single aim to win the game, and also to recognize, resolve interactions issues. To avoid the interaction issues between the multiple agents, researchers found a synchronizing agent which implements and revises the plans based on the situations. Self-interacted multi-agent interactions are that they're self-interacted. That means these agents, these multiple agents are having individual goals to do, like they don't work as a team. They do work independently to achieve their respective goals. Aspects of successful interaction is that negotiation. They do need to negotiate which agent need to do the task first and the other as per the priority. Ability to adapt to the changing circumstances. These sense the circumstances and do change the plans according to the criteria. And the negotiation models concludes that the only one learning model has a harmful overall impact on the system performance. That means if a single agent has its own priority, then the whole system cycle will change and it will impact the performance of the system. The issues with these issues and future directions with this system is that due to network like congestion, to communicate with them in a matter of time, they need to be very fast, and we are not supposed to have any delays in responding to the other agents' response. And second, community of self-interest computational agents can be behave in a chaotic or oscillatory manner. That means if they work in different, like on their goals, it will be difficult to communicate them to do a single prescribed goal. Increasing the decision-making abilities of systems individuals may increase or worsen overall system performance. To improve their individual usefulness, agents may be to have their individual to improve in the process of improving their individual performance. Agents may be untruthful. That could lead to the problems in the system. Some of the applications of these are key domains. They're used in industrial applications where processing, it might be processing or any type of application where a sequence of operations are required, and commercial applications, enterprise applications, and medical applications. Industrial applications. The industrial applications of the systems are manufacturing industry and process control, telecommunication, air traffic control, transportation system. Manufacturing means like different units have different products, and different products have different sequences, and these to be aligned by using multi-agent systems. And as I said, air traffic control, they need to plan the operations of a flight with respect to the other flight operations. Commercial applications. They are used in information management, where the information filtering and gathering is very much important. Information filtering is that we are getting large volumes of data on daily basis, that we need to filter the information as per the needs of the system. And information gathering is one aspect where we need to collect a lot of data and to feed to the agents to perform a specific operation. And electronic commerce, in the for example, if in these days we are having artificial intelligence systems where they're sensing our shopping data and they're giving the suggestions which one to buy and where we are getting this special product for lesser prices. And for business process management, where the systems are taking the decisions based on the performance of individual departments, and they're analyzing that data, they are getting the data, analyzing the data, and they're predicting the possible solutions and giving the results. That's where I'm concluding my work, and Sai Charan will continue after this. Thank you.
Hey guys. So myself, Naga Sai Charan, I'll be going over two applications were discussed by Arjun, and other two applications will be discussed by me of multi-agent systems. And I'll be discussing over the paper 2, which is multi-agent learning of engineers. The paper is by Manoj Shea and Jeff S. Sharma. So I'll be going over the applications first. So the applications in entertainment applications. So basically, a lot of people think computer science field doesn't have much of influence in the whole leisure industry. but the leisure applications are often thought as a separate from the serious applications of the computers. But they do have a prominent role. There are a lot of agents which are involved in entertainment industries, and these are considered to be very hard and profitable. Uh, so to that, the author has given two examples. One is games and one is interactive theater and cinema. Uh, in the games, author have actually mentioned Grand and Cliff, which they have used agent techniques to make a popular game. They call it as creatures game. So where they play in a rich stimulated world. There are a lot of synthetic agents that will interact in the real time. These agents are actually supposed to be a well-educated pets, which grown up and based on what they have done in their lives. In the interactive cinemas, they have mentioned about the characters which have behavioral traits as a real humans. Next slide, please. Coming to the other application in the medical industry, so basically it's not surprising that agents are being used in the medical industry. So they have mentioned two main areas in the medical industry, that is patient monitoring and healthcare system. uh, in the patient monitoring, it is actually intended to management of patient care, that is in intensive care unit. uh, so the fact is basically patient care model in SICU, that is surgical intensive care unit. So where the group of experts of diverse area of expertise collaborate to organize this patient health care. So the second one is the most important factor of good patient care health is actually adequately sharing the information between the members of critical care team. Uh, there the multi-agent system is very useful. And coming to the healthcare system, they in the studies references they have actually pointed out a prototype agent-based distributed medical care system, which actually involves large number of personals in the most cases. So where the multi-agent is being used. Can we go to the next one? So in the future directions of the whole thing, so multi-agent systems can be deployed only where there is a trust. So basically, trust is a prerequisite for people to feel confident that delegating these jobs to the agents. Uh, when an autonomous software components are to be extensively used, the people and the organizations both have to grow comfortably when and should be familiar with the concept when they are delegating these jobs to the agents. So users should basically have faith in the agents who represent them. So this will might take a time. For the conclusion, authors have actually mentioned autonomous agents actually evolved over the decades. There are many key conceptual breakthroughs which occurred in design and implementations. How they interact with one another, it was mentioned in the conclusions. There are commercial goods and software solutions. On the other hand, they are starting to include these in technologies directly. Uh, so there are number of basic research and development difficulties still persist. Can we go to the next one? So here in this slide, we are going to discuss about the abstract and introduction about the multi agent learning for engineering. So the authors actually presents a problem uh, by giving an examples of the problems in the engineering and talking about how multi-agent learning might be helpful to solve these problems. So there, in addition to that, authors also point out engineering applications don't use models that are usually used in economic game theory literature. So this is because there was underlying assumptions and issues which concerns are different. Uh, so where multi-agent learning in the engineering applications comes into the picture. Coming to the introduction, the authors have explained the advantages of multi-agent learning and in a potential application to develop a distributed control, where the area of control theory that deals with designing and analyzing many controllers that work together to meet the design criteria. Can we go to the next one? So why multi-agent learning? The multi-agent perspective allows one to see the larger system into a collection of smaller, more easily interconnected components. And it should be noted that it entails deciding to use a multi-agent framework as a design strategy. So therefore, the design making process of any single component is detected by an optimization problem. Can we go to the next one? So there are a number of challenges which are defined in aspects of this multi-agent learning. So there are 5 which were mentioned in this. That is defining the game, Nash equilibrium, performance, convergence, and averages, and limited information and costly communication, and learning dynamics and bounded rationality. So in the defining of game, they actually discussed the actual definition of agent utility functions. So which is basically defined once the design is been confirmed and where the strategy spaces has been described properly. So the ideal scenario of this centralized purpose that everyone will be agreeing on is there are essential uses to taking care into account while distributing this objective among many participants. So coming to the second point of Nash equilibrium, so the significance of this specific thing in a designed systems is necessities that development of several arguments. So the general notation of this algorithm is to give a good solution, maybe represented in terms of the specific algorithm, where the specific game that has correctly specified, despite the fact that it is not a perfect game, but the scenario where the multi-agent learning has been set up properly. Coming to the performance convergence and averages, there is the use of these happens in the averaged measurements, which includes the concepts of correlated equilibrium and regret and calibration. So the average performance criteria is actually defined as a representative state of steady state activities. So where the performance of the whole multi-agent system can be derived. Coming to the next point of limited information and costly communication. Uh, so the information is a key thing in the multi-agent system, and how it is accessible to the each agent. There are multiple agents which are involved. So at a particular time, the agent, the cost of communicating the information between one agent to another agent is called the limited information agent. Arjun, can we go to the slide? Yeah. So coming to the learning dynamics and bounded rationality, there is no means can we go to the next one, the previous one? I'm still discussing the 5th point. Yeah. So coming to the learning dynamics and bounded rationality, there is a full list of engineering designs which actually concerns the multi-agent learning. So it continues to increase as economic techniques of engineering problems are investigated. Next slide, please. So in the concluding remarks, authors have additionally mentioned two different systems, two designated systems. There are significant things. Those are robustness and the domain knowledge. Robustness is nothing but a control theory which is defined to withstand changes in the parameters of nature and the anticipated input. When coming to the domain knowledge, it is a critical component where the specification of system engineers has been defined, and multi-agent learning algorithms are now available are often really simplistic, and they do not have any domain knowledge into consideration at all. Can we go to the next one? So this is the conclusion of our presentation. So in the roadmap of agent research, we have discussed autonomous agents, different types of multi-agent systems, issues related to the multi-agent systems, and applications in different sectors like industrial, commercial, entertainment, and medical. In the multi-agent learning for engineers, the author's belief was to multi-agent learning paradigm, which is derived from the economic game theory literature, has significant potential in solving critical engineering issues, and they look forward to see this path continue to develop in years to come. Thank you all.